So in this video, we're going to be looking at the mouth and the esophagus. So let's start with the mouth. So the mouth is really where things start, and we probably could say that digestion starts even before food enters the mouth. We are triggered by the smell and the sight of food. You probably have had this happen to you where you smelled something and all of a sudden you felt like your mouth was starting to water, maybe your stomach started to grumble. And the reason for that is that your body goes, oh my gosh, food might be coming. And so it actually signals the digestive system to start things rolling, because we definitely want to have saliva in your mouth, acid in your stomach, all those things that are important to digestion. We want those to get started being produced before food even enters into the mouth, so that we're ready to go once food is there. In your tongue, we have different taste buds. You probably have learned that from the time you were in grade school. And we used to say that there were certain sections of your tongue that we tasted certain tastes. And we've actually realized that that's not really true, that we have taste buds all over your tongue that are going to taste all of the major tastes: sweet, sour, bitter, salty, and umami. Umami is the one that you might be less familiar with. That's kind of a savory flavor. I always think of like soy sauce or miso paste or something like that. And different people taste things differently. So you might be a super taster, where everything is like super intense in terms of flavors. And you may find that things that are like really bitter are just too intense for you, or sometimes things that are really hot and spicy are too intense. So our taste does change over time. We're going to see that little kids have much more intense tastes than as we get older, and certainly older adults do tend to lose their sense of taste a little bit. So of course, we also find that our sense of smell also contributes to that sense of taste. We've all experienced having a cold and nothing tastes very good. We're also going to find that we have a lot of mechanical digestion that happens in the mouth. So we're going to start by chewing that food to reduce it into smaller particles. We want smaller particles. For one, it's hard to swallow a really big hunk of food, so that's the first reason. And two, we're going to see that once we get into having chemicals react with those particles of food, smaller is better because we have a lot more surface area. We're also going to have some chemical digestion, and we're going to talk a lot more about saliva and what it contains in just a second, but saliva is going to be our big chemical carrier in our mouth. So what makes up saliva? Well, saliva is kind of a watery fluid that's, of course, produced by our salivary glands in our mouth, and they're going to contain a lot of different things that we need. So one is lubricants. We're going to find that we need to get that food moistened and lubricated so it'll slide down that esophagus a lot better. We probably all have eaten something that's really dry and felt it kind of get stuck in your throat, and we know that's no fun. We also have enzymes that are going to be chemicals that are going to start to break down nutrients and other substances. One of the enzymes that we find is in high concentration in saliva is the enzyme amylase. And we're going to see amylase occur again, but amylase is going to be that starch digesting enzyme. And so we're going to have to use that to break down carbohydrate types of foods. So your breads and your pastas and crackers and things like that. If you actually want to see or taste, as the case may be, amylase in action, take a soda cracker. So take a saltine cracker, and it also works with a piece of bread, and put it in your mouth. Chew it up and let it sit there for a while. It gets really gooey and gross, but if you let it sit there long enough, you'll actually begin to taste a little sweetness. And that is those starches being broken down just a little bit into more of that sugar. Your pancreas is also going to produce amylase, so we'll be coming back and talking about that again. We'll see that lipase is another enzyme. So that's a fat digesting enzyme. And we actually, as adults, don't have as much lipase as we do as kids, especially infants who need it more to start digesting all the fat that's in breast milk. But it's okay that we don't have a lot as we're adults because we also have lipase in our stomach and our pancreas. Now keep in mind that because we tend to eat really fast, amylase and lipase really don't have a whole lot of chance to work. So we're not relying on them a lot, but they do begin that digestion process. We'll also see that saliva has a lot of mucus, and we're going to see mucus all throughout our digestive system. We're kind of gooey, mucusy people when it comes to the digestive system. And this is actually going to help us a lot with lubrication. So in terms of why we want it in our mouth, we want something that's slick when we try and swallow it. So that's really the big reason that we would like to have mucus and when we look at that saliva. We'll talk about it again because, again, we'll see it in other places. So once we have gotten things to the point that we're ready to get them out of our mouth and down to the stomach, we're going to use the esophagus. So the esophagus is basically just a long tube that's going to connect the pharynx, which is at the back of our mouth, we'll see that again in a second, with our stomach. And it's a muscular tube. So we think about this as being sort of a passive type of action, but in reality, it's not always that passive. Sometimes we're going to need a little bit of muscle contraction in order to squeeze things down. It depends a lot on what we're eating. So if we're doing something liquid, it's pretty passive. However, we probably have all eaten something that felt like it got stuck in our throat, and we actually felt that kind of squeezing as we move things down. Now, in order to just keep things where they should be, we have these sphincters, these tight muscular rings that are going to separate one organ from the other. So the first one that we come across is going to be the lower esophageal sphincter. And that lower esophageal sphincter is going to be between the opening of the stomach and the esophagus. And the reason that we want this to be there is that we don't really want stomach contents coming back up into the esophagus. When that happens, that's pretty hard on the esophagus. It doesn't do well with having a lot of acid. The stomach's designed for it, but the esophagus isn't. So once things get into your stomach, we want them to stay there. So that ring, that lower esophageal, or sometimes we'll call it the gastroesophageal or cardiac sphincter, will open briefly to allow contents to come down in through the esophagus and into the stomach, and then hopefully it closes up again very tightly. So we talked about that pharynx at the back of your mouth, and it's interesting to see how we actually swallow. So we're going to take that bolus of food. So as we've been chewing around, we get it kind of mashed up, and it ends up to being kind of a ball. And keep in mind that we probably don't even think about this. If your swallowing mechanism is working as it should, you won't even notice what's happening. So our tongue is going to work this food to the back of your throat. And when you're ready to swallow, we have the epiglottis. So the epiglottis is kind of a muscular flap that is going to either send things down the trachea, which is happening most of the time as we're breathing. But anytime that we eat or drink, we don't want things going down the trachea to our lungs. That's bad. We hack and we cough and we gag when that happens. So instead, we want that epiglottis to cover the trachea and open up the esophagus so that we can have things go down the right way. Now, it's kind of cool to watch this swallowing video. So let's see if we can get that going here. Take a second. So basically what we're looking at is this is going to be just a way of us seeing that swallowing mechanism. And so we're not really going to be looking at necessarily food. They might have done something else. But when we look at people who have problems, I things are being a little pokey here. When we have problems with swallowing.
Two stages, the oropharyngeal and esophageal stages. At the start of the swallow, a food bolus is voluntarily pressed by the tongue up against the roof of the mouth, backwards towards the pharynx. In response to activation of pharyngeal pressure receptors, the swallowing center in the medulla initiates reflexes that prevent food entry into respiratory passageways. The uvula contracts, which blocks the nasal passages from the pharynx. The laryngeal muscles contract, closing the glottis at the top of the trachea by tightly aligning the vocal folds. The epiglottis swings down upon the closed glottis. With all airways blocked off, respiration is temporarily inhibited. As the upper esophageal sphincter relaxes, pharyngeal contractions drive the bolus into the esophagus. The oropharyngeal stage is done, and breathing resumes. During the esophageal stage, a primary wave of peristalsis initiated by the swallowing center pushes the bolus through the esophagus. As the bolus travels through the esophagus, the lower esophageal sphincter relaxes, allowing the food to enter the stomach. If the bolus is sticky and adheres to the esophagus, secondary peristaltic waves triggered by the intrinsic plexus at the point of distension completely clear the esophageal lumen to finish the swallow.
So that hopefully, and I'll post the video, the swallowing video, as a separate post. So if you want to look at that again, you can. But you can actually see that food going down. And that's an important piece to remember, is that it's hopefully going to be triggered automatically. But we do see that people that have had maybe a stroke, people with Alzheimer's, people that have neurological problems like Parkinson's or MS may have some problems initiating that swallow. We also find that kids do too. That swallowing reflex is sometimes a little bit dicey in kids until they kind of get more control over their muscles. So in the video that you saw, and then I've also mentioned this, we have this thing called peristalsis. And peristalsis is going to be that muscular contraction. And again, most of the time we don't even feel it, but we're going to see that that contraction happens above our food mass, and then it squeezes and the food moves down. We do another contraction above that food, it would move down, etc., until we get it moved all the way down into your stomach. Once that happens, again, that lower esophageal sphincter will close and food will be in our stomach, which is the next step on the way.